In this video, I will be talking about deflection of subatomic particles and ions in an electric field. Suppose we have two charged plates, a negatively charged plate and a positively charged plate. And through those charged plates, we are passing beams of the three subatomic particles, a beam of a neutron, a beam of a proton, and a beam of an electron. We will see that the neutrons will pass straight through the charge plate without showing any deflection. This is because the neutrons does not have any charge and it is not attracted either towards the positive plate or the negative plate. But the electrons will be attracted towards the positive plate because the electrons are negatively charged, and the protons will be attracted towards the negative plate because the protons are positively charged. But we will also see that the electrons are deflected by a very large degree compared to that of the protons. The protons will be deflected by a small degree. The reason is because the protons have a large mass, and as the protons have a large mass, they will show little deflection because they will have a large inertia. On the other hand, as the electrons are comparatively much lighter than that of the protons, the beam of electron will show large deflection. Now, if we pass any atoms or ions, they will be deflected according to their charge and mass. For example, if I pass any neutrons or any atoms or any uncharged particles, it will pass straight on because they are uncharged and we will not be attracted towards any of the plates. But if we pass any positively charged particles, it will be attracted towards the negative plate. And if we pass any negatively charged particles, it will be attracted towards the positive plate. The degree to which an atom or ion is attracted towards the positive or negative plate will depend on their charge and mass. The higher the charge of a particle, the greater its deflection will be. And the higher the mass of a particle, the smaller its deflection will be. That is to say, deflection is directly proportional to the charge of a particle, and deflection is inversely proportional to the mass of a particle, given that all of them are traveling at the same velocity. And we can combine this to actually come up with the formula: deflection is directly proportional to charge by mass. And we can use this formula to answer questions like this. Which of the following ions will be deflected towards the greatest extent in an electric field? To answer this type of question, you need to find the charge by mass ratio for all the particles. The particle with the greatest charge by mass ratio will show the greatest deflection. So I have found out the charge by mass ratio of all the particles, and as we can see, the charge by mass ratio of the nitrite ion is the greatest, and so the answer to this question will be D. As nitrogen has the greatest charge by mass ratio, it will show the greatest deflection. Now we can also remove the proportionality sign from this reaction and come up with this equation. K is the proportionality constant, and we can use this formula to find the deflection of two particles that is being passed through the same field. So in this question, a proton is passed through an electric field and is deflected by an angle of -30 degrees. What will be the deflection of a lithium negative ion if it was passed through the same electric field? So first, we need to find the value of K for the particle of whose mass and charge and deflection is already known. So we know the mass of a proton is 1, we know the charge of a proton is +1, and we know the deflection, which is already given in the question, -30 degrees. And we can use this to find the value of K, which is -30. Now, if we use this value of K for the lithium negative ion, then once again we know the mass of the lithium negative ion to be 7, the charge of the lithium negative ion is -1, and the value of K from the previous part is -30. And when you place all of them together in the equation, then we can figure out the deflection to be +4.286. Pause the video and give this question a try. The answer to this question is B. Pause the video and give this question a try. So let's give this question a try. A stream of gaseous oxide ions are passed over two oppositely charged plates. Analysis of the deflection shows that the ions deflected at an angle of 10 degrees. Under the same electric field, an unknown gaseous ion, Z-, is deflected at an angle of 2.58 degree. What is the isotopic mass of Z? So, for the oxide ion, we already know the mass of the oxide ion, the charge of the oxide ion, and the deflection of the oxide ion. And using this, we can find the value of K. And then using the value of K, we can find the mass of the ion Z. The mass is unknown, so we have to figure that out. The charge is -1, as the charge on the Z- is -1 already shown, and the deflection is 2.58. It is already given in the question. And we put all the information in the equation and solve it for mass, and we get the answer to be D.